you're muted up here right now.
Okay, thanks.
Whenever you're. I'll just make sure your video works. Do you have any audio?
No, just
Oh, okay.
just my face.
Just your face.
Move the obstacles so I can gesticulate.
Oh, that's like our love seat for the Elixir.
Was that structural?
Yeah, you were supposed to. One of us was gonna sit there. And
Oh, it was gonna be a panel
Yeah.
interview.
You offered me to ride shotgun with him, Tim?
Yeah.
Cool. Ideally, I want to unmirror.
Oh, it's on your touch bar.
How do I unmirror?
Oh no, it's not. It
I
didn't show up.
probably reconfigured mine.
Okay.
I thought-
Arrangement.
Oh, arrangement. Yeah.
And then, it usually shows like extend or mirror on there when you plug something in.
Oh, I should look into how I turned that off because I did it so that the escape key is always there.
Hold down
Like
function. What happens if you hold function? Oh, never mind. Just forget
There's
it.
probably a way. I'll have to go look later.
It's fine. Whatever.
Yeah, there were quite a bit. Next year we might be shut down.
Who wants to read my emails?
Yeah, we got.
That'll be fun.
So pizza's here. So if you want, grab some pizza, and we'll wait a few minutes and give Greg time to prepare, and then get started.
is.
So I think we should probably do introductions because there's maybe a couple new people. Or we haven't done it in a while and the internet's watching, is that right? Should I tweet that? Yeah, last time we had people from New Zealand watching, so.
And it's 2017, it's not a big deal.
Yeah, it's not a big, yeah, it's like old hat, you know. Let me grab my computer so I can do that, so I don't have to. Tim, send me a link and I'll tweet it.
You assume that I know technology well enough to do that. It's very early in the morning in New Zealand.
Yeah.
Yeah, what were they doing watching this?
I don't know, man.
It's not this. This is the wrong link.
Kiwis, I don't know.
Like look for Gaslight Live, maybe.
Yeah, I think it's Gaslight Live.
Not Gaslight Dead.
Yeah.
That's different.
We're gonna try to get a loop going.
That's actually not a bad plan. I was just looking up the link for James.
Yeah.
So click here,
Yeah.
and then click here. This is gonna do bad things. That's actually
We can do the whole Spaceballs thing, like when will then be now? Soon.
There's enough of a delay that it doesn't feed back, which is actually kind of cool. So did you want to tweet this?
Yeah.
Oh, you want me to tweet this?
Yeah, tweet it, and then I'll retweet it. Yeah.
Oh, hey, how about that?
So. Okay, do you want to introduce yourself before we tweet the link out? Okay.
Too late. This is going to be too distracting. There we go.
All right. Okay, so let's go around and do introductions. I guess I'll kick off. Just say your name, maybe where you work if you want to, and what you've been doing with Elixir lately. So my name's James Smith. I work here at Gaslight. And really the only thing I've been doing with Elixir lately is kind of mentoring a couple of the projects we have here. There's some cool stuff going on, but it's a lot of like Docker or like Erlang OTP stuff. So that's it for me.
My name's Kyle. I work over at TCS in Milford. There I do stuff completely unrelated to Elixir. It's mostly container orchestration kind of work. I haven't done much lately, but a few months ago I was hacking around with some stuff doing GraphQL with Elixir. That's about it.
I'm Chris. I work here at Gaslight as well. Haven't been doing much with Elixir lately, but yeah, one of the last things I was looking at, I was also digging around in Absinthe and seeing what was up with that, which is a GraphQL server in Elixir. It's kind of fun.
I am Jason Vegley. I work at a company called Mefford, and I am working on a new product there, an alerting system called Ropig, which we're building from the ground up in Elixir and deploying to Google Cloud Platform, so that's kind of fun. Other things I've been doing recently with Elixir is I'm maintainer of a couple open source libraries. One is called External Service, which is used for interacting with external services safely and reliably. And the other is called Wait For It, which is allow you to wait for things to happen in the background.
I'm Paul, and I do programming, Ruby, done some Erlang, and I just use my Elixir from above.
My name is Ben Stafford. I work here at Gaslight. Definitely coming from the Ruby Rails background. Haven't had a chance yet to do Elixir in production. Currently doing the advent of code stuff in Elixir. We'll see how that goes, see how far I get, but I'm already behind. So that's it.
Maybe we could put some of that up on the screen if there's time.
I'm Tim Mecklem. I do some stuff with Elixir sometimes. The most recent thing I've done is I used Greg's NeoPixel library and Raspberry Pi Unicorn Hat to scroll nice messages to encourage people here. That was fun. So that's it.
I'm Jeremy Kane, work at Gaslight. I've typically done Ruby on Rails, but I'm really excited about Elixir. I worked on a project for like 2 months at the beginning of the year, and I'm getting ready to start a new project, or I just started a new project. So I'm really looking forward to that.
I'm Zach Kaiser, and I work here at Gaslight. So I haven't done anything in production in Elixir yet, but I have a side project I have in Elixir that I've recently been rewriting and refactoring a bit. That is essentially an engine for a Texas Hold'em game. So that's fun. And I actually finished my Elm client for it yesterday. So that's cool. Yeah.
Ed Summerfield, I work for Plexus. We are using Elixir to drive payment terminals. And in my spare time, I'm playing with Elixir to build a battleships game, which I'm hoping to roll out to you guys at some point in the near future. Zach and I have been working on that. It's kind of a reinvention of Jason's idea, but we had to rewrite it from scratch because we're learning Elixir, right? There's no point using something else's stuff.
All right, I'm Paul Spencer from a company called Palmiette. My Elixir experience is mostly from beginning of the year, writing out some prototypes of some products that we're building. And then recently just messing around with different, different models to help our sales team and pull in different information off the web. So maybe if we have time today, I'd like to show you what that looks like.
I'm Matt Silbernagel. I work for Engage Partners. Lately in Elixir, I haven't done much. We have some Phoenix projects at Crossroads where I'm at, but I haven't been able to touch them much. So I've been doing some side work. I'm building a product for myself that pulls in some NPR data. So I'm building a little NPR library in Elixir that if any of you need that data from NPR, I'll have it soon. That's it.
I'm Ken Baum. I Engage Partners and also at Crossroads. I'm working on a blockchain block parser in Elixir, and I'll show you what I've got in a little bit if we have time, and we'll find out more then. So
That's awesome. Looking forward to that. All right. So if you're joining us from the internet, welcome to the Cincinnati Elixir meetup. Tonight we have Greg Mefford, who will be speaking about his conference. He's going to be giving his conference talk that he gave at Elixir with Love, and we get to see the final version of it. So I'm excited about that.
Yeah, so this is like version 3, post-production. Strikes again. All right, cool. So I'm Greg Mefford. I work at Latote, and this is my Elixir with Love presentation. The title of the talk was Functional FullStack Systems with Elixir, Phoenix, Nerves, and Elm. So I wanted to go through what I mean by each of those things in reverse order here, starting with systems. So you're probably all familiar with the monolith. This is the thing that you start with when you're first starting out with your code because it's the only thing you have. By definition, it is a monolith. On the opposite end of the spectrum, you might be familiar with microservices, which is the same thing, only smaller. Each microservice is going to have some small responsibility in the system and ideally be isolated from the others in deployment and whatnot. It's also common to have a hybrid architecture when you're transitioning or maybe as a permanent step in your life cycle. And then it's also possible to have a split monolith or multiple monoliths as maybe a design anti-pattern, but also possible. So there's this thing called Conway's Law that says that the structure of your organization often guides the structure of your software. And something that I learned, fun fact, while I was researching this talk is that was first coined in the Mythical Man Month which despite its awkwardly gender-specific title, is a really good book. If you haven't read it and you're a developer, you definitely should. One of the important concepts that this book brings up is the concept of cost of communication in your teams. So this is a caricature of a team of co-founders, a couple of co-founders. The communication cost is pretty low because there's only 2 brains involved and 1 lossy channel in between them. As you add more people to the team, this isn't really a big deal. There's still only 3, but there's increased chance for missing things because now you have more communication links between the people. And as the team gets really big, it needs to be partitioned somehow because this basically is just everybody having meetings all the time and misunderstanding each other. And then at a certain size, it's basically impossible to communicate with everybody. You can't even draw the lines. So you have to have some kind of structure there. Ideally, small teams would be formed with autonomy and responsibility so that teams are working on individual services that are also isolated. You might want to have overlapping teams like team leadership or front-end engineers that need to get together and argue about whether they should use Gulp or Webpack or Grunt or NPM, all the things. So I also wanted to just mention it's a good idea to encourage informal communication between people, not necessarily part of certain teams, because that builds empathy across the organization, and it also leads to meeting your business needs more quickly because people already have some context and understanding. So my takeaways here, I want you to think about both the technical and the organizational systems as we go through the rest of the talk, and then minimizing the communication overhead, but encouraging empathy. And Conway's law says that this is a requirement to building microservices, so it's not just a good idea, it's the law. So let's talk a little bit about full-stack systems. This is what you might think of as a back-end engineer. They write code that runs on servers. Sometimes the same person is also a front-end engineer, where they write code that runs on a laptop or a desktop computer. And sometimes that's called a full-stack developer. They also might be responsible for configuring the servers, databases, network, firewalls, security, monitoring, other things. Sometimes that's called full stack. They might also write front-end code that runs on mobile devices like phones. Sometimes that's called full stack. But let's not get ridiculous. Like sometimes we need native apps, and that's too far. But what if your business is more than just a website? What if you have logistics to manage, you have RFIDs, barcodes, GPS, fleet tracking, that type of stuff? Who's responsible for that? Well, usually that's outside the stack. So there's probably contracts involved, there's probably spreadsheets involved, there's probably consultants involved, and your developers just are not involved at all. If you're lucky though, there's an API that your vendor provides that your back-end engineers can use to access the sweet goodness that's on the other side. If you're an IoT company and you have these devices that are actually your responsibility, you may have somebody that has the same type of skills that can talk to that back-end API. Or maybe you have a manufacturing process that has some automated process control, some human-machine interfaces. Unless that's core to your business, there probably is no API, and you're just setting up a contract with the person down there to reconfigure the device, or you're dealing with whatever it does out of the box. So the takeaways here, you should think about what full stack means for your company because maybe you don't have devices, maybe that's not relevant. But if it is, then maybe your back-end engineers and your front-end engineers can work on the human-machine interfaces and the barcodes and RFIDs and all the things and take more direct control of your whole stack without all the contract negotiation and slowdowns. And finally, let's talk a little bit about what functional full-stack systems means. So the obvious thing here is functional means that it actually works over time. It gets bad and then it gets better. Also, you might notice that it gets a little bit better than it was at the beginning. And ideally, that's because we want anti-fragile systems that are resilient to failure and also get better over time in response to dealing with failures. The poster title of that is the Netflix Chaos Engineering Team. By injecting failures into their running production environment, they can actually make it better over time by having failures. This is not what they meant by let it crash when you're building Erlang systems. These photos are courtesy of Kevlin Henney's Twitter stream, where you can find more of these, if that's your thing. The other definition of functional is that it's actually the functional programming style. I feel like this makes the code easier to understand and reason about, more deterministic, because you have certain outputs for every given input without side effects. So that brings us to the happy family that we're talking about here, Elixir, Phoenix, Nerves, and Elm, and building full-stack systems with those. But first, in full disclosure, I would like to introduce myself with a story. I work at Latote, where we're enabling women's fashion through subscription rental service. And specifically, I work on the team that uses Elixir, Phoenix, Nerves, and React to make the magic happen in the fulfillment centers. That's right, I didn't say Elm. We definitely have several people that are looking at it, but we haven't made that jump yet. But anyway, we're hiring, so if you are interested, let me know. I've been contributing to the Nerves project for a couple of years, and since this talk was given at a conference about the Elixir community, I wanted to share my story a little bit and let people know that if you feel like you don't have something that you can contribute to the ecosystem, I want to tell you that, first of all, you're wrong, but also you can contribute a lot of things to the community if you'd like to, so don't feel like you can't. Like many people in the Nerves community, I found out about Nerves from watching Garth's presentation at ElixirConf 2015. I had some electronics experience and a Raspberry Pi that I basically hadn't powered up after buying it a couple of years earlier. And I struggled through the process of getting Nerves working on there. And I was really excited because there's this visceral experience of having physical hardware on your desk that you told it to do something and it did it. So there's Hello World over there, and I was pumped. And then it was time to make some things blink. So that's where the Nerves NeoPixel library came from. And then I realized I really wanted to get involved in this Nerves thing, even though I was new to Elixir. And then when I thought more about it, I realized that I had something to offer to the project because I was new to Elixir, and I could help new people get involved. But I had pretty limited time and energy. This is a picture of me and the kids hanging out on the weekend. So I decided to build a welcoming and friendly community for Nerves. And for example, I started to manually and individually welcome each new person to the Nerves channel in Slack and invite them to get involved. And over time, I branched out and started helping in other ways too. There wasn't really any formal process involved in getting involved. I just reached out to the existing core team members on Slack and said that I wanted to help out. And they were happy to help with things. They were happy for me to help with these things that are often overlooked in open source projects, like answering questions. The community's grown a lot. We have over 1,300 people in the Slack channel today. And I see that as the tip of the iceberg because there's tons of people that don't use Slack, don't know about Slack, are engaging in other ways, or not really engaging at all, and they're just using Nerves and enjoying it. So recently we've been reaching out to places like Elixir Forum and Stack Overflow where we can kind of meet people where they're at a little bit better. So now that you understand my particular bias toward Elixir, Phoenix, and Nerves, let's talk about how to build functional full stack systems. For each part of the stack, you have a lot of choices. And the overall result is not always the best. So for backend tools, Ruby on Rails is often popular, but not functional. I'll let you take that how you will. Clojure is functional, but actually you don't even need a web framework because it's just functions. But I think Elixir and Phoenix are really good choices for full stack systems. That's what we're going to be talking about today. Due to the Erlang tools, the Erlang roots of Elixir, it's a really great fit for embedded because today's low-cost systems, were yesterday's supercomputers, with Raspberry Pis being as powerful as the old systems that Erlang was designed to run on. So it's unsurprising that the Beam would work well there. But I want to talk for a minute about a particular 1-2 punch that I see here: per process garbage collection and immutable data structures. Anybody who has an ops background will recognize that this is a memory graph for the JVM. The shaded areas are waste because basically the garbage collector hasn't freed up memory that you're no longer using yet because it doesn't have a way to quickly determine that due to non-immutability in Java. If you zoom in, you see the same process. These are just incremental garbage collections over time. When the memory hits the 75% threshold by default, that's when you get your big garbage collection where we say, hold everything, let's figure out what's freeable. And that can actually take a while in a busy system and cause a lot of problems. By contrast, this is what the Beam garbage collection looks like because it does the garbage collection on a per process basis. I actually did check this on like a production system that we have because I was like, I'm going to say this, but then it's not going to be true and people are going to be upset. So it's true. There's very little waste for a system that's under constant load because the overall memory usage just ebbs and flows with the actual demand that's on the system. And let's zoom in a little bit and see how that works. Basically, since you have garbage collection happening across all these processes independently, at any moment in time, there's a small increment of memory getting added to each process, but then there's also a chance that some process is going to be done with all of its memory, right? So like probabilistically, you're going to be pretty steady if it's a constant load. So another thing that's really great about Elixir is a binary pattern matching for embedded systems. In this example, let's pretend like we have a data sheet that says we have a 3-bit operation code and a 6-bit address and 7 bits of data that we need to parse out from this response from the chip. That's pretty easy to do with binary pattern matching in your function head. But then, by the way, the data sheet says that if you have the first 2 bits being 0, then you go into extended address mode, right, where you have 9 bits of address and 4 bits of data. So in a procedural language, you would have to write around that with some if clauses, cases, whatever, but you just can add another function head to Elixir and it does the right thing. Next, let's talk about Phoenix. This is your server on IoT. And it turns out that Phoenix is pretty good at handling that because without much special tuning or re-architecting, it can handle a lot of WebSocket connections, for example. In this presentation, Gary describes how they were able to get a single server to host 2 million WebSocket connections. And that wasn't really the limit of what's possible. That was just where they stopped because they ran out of time and motivation to keep going, try to do more. Phoenix does a good job of using all your cores, whether it's 4 cores in your Raspberry Pi or tons of cores in your big physical server. And Phoenix is also pretty secure by default. In this presentation, Griffin presented his findings from analyzing a bunch of Phoenix project source codes that were available. My main takeaway from his presentation was that you're pretty secure by default, and Phoenix just does the right thing most of the time. Phoenix also makes a great embedded web server, whether you need a configuration page, a human-machine interface, or just a JSON API for a headless device. Phoenix channels offer a great way to easily connect your devices to a server, whether it's an app running in a browser or a headless device in the field. I'm also really interested in this GraphQL subscriptions thing that was demonstrated by Bruce and Ben at ElixirConf, but I haven't had a chance to try it out yet myself. In the embedded space, there's also a bunch of options. You can use Johnny 5 if you're into JavaScript. Grisp is an interesting option if you want to run Erlang on specific hardware that's designed for running Erlang on the metal. Or you can just run a Raspberry Pi with Linux and whatever language you'd like to do. But I don't recommend that because that's what Nerves is for. And we basically just put Elixir on a Raspberry Pi, and there you go. It's pretty easy. So Nerves uses buildroot to cross-compile a minimal Linux kernel in userland for you. It's much smaller than normal Linux installation because it doesn't include all the drivers and tools that you need to support a bunch of hardware that you're not using. We have a small init process called erlinit that just boots up the beam and your app. That's all it does. The Nerves team packages these up into what we call systems. And they're specific to a given hardware target like the Raspberry Pi Zero, so they have just the minimal things that you need for that. You can make your own if you need to, if you want to add things, and we have good documentation about how to do that. When you build a Nerves firmware, it adds your application code to the precompiled system to build your Nerves firmware. Your application is responsible for starting up any daemons that you want to have, for example, using an Elixir port. And then the firmware runs from a read-only file system on the device, which protects you against corruption if you're trying to write somewhere you can't mess up your boot partition. And to solve that problem, we also have an app data partition where you can write to your heart's content without corrupting the other partition. There's also a secondary firmware slot where you can push, it's writable, so you can push a new firmware to it and then configure it so that when you reboot, it'll boot into that one instead. And we also have bootloader, which gives you app-level fault tolerance. This can be used to ensure that the device comes up in some consistent state, even if your app doesn't start properly. Nerves has support for a bunch of targets that are popular these days. The Raspberry Pi family, BeagleBone family, and Lego EV3, which I think is pretty neat that you can run Nerves on Legos. Nerves integrates really well with the Elixir ecosystem. It's just your standard mix tools that you're used to already, mixnerves.new to generate a project, all the way down to burning firmware and pushing updates. This is kind of a sketch of a successful architecture that we have at Latote for using Nerves in production is not necessarily Raspberry Pi, but some device running Nerves and Phoenix, running an Elixir-based app on the device, and then some browser running a front-end application that connects to your server and to the local Nerves server, and then can display a web page. And the great thing about this is that you can do the same thing in development on your laptop. You can have Phoenix plus mocks of the hardware, and then you can control those using IEX, and everything just works the same way as it really does. So you don't have to have real hardware available for testing. Also works in CI. So let's talk about front-end tools. The problem with the JavaScript ecosystem is that there aren't enough choices. If you're into Ruby, you can use Opal to compile into JavaScript if you want to. You can also do the same thing with Elixir, using Elixir script, which doesn't have a logo for some reason. And then Clojure, you can do the same thing with Clojure script. But the problem is that these languages weren't really designed for web development, right? They were designed for general purpose computing, servers, various things. It's not really front-end specific. So maybe you want to go with something like TypeScript or CoffeeScript or PureScript, which were designed for those things. Or maybe you just want to use regular old JavaScript with React or Angular or Ember. But then as you mature, you'll probably realize that you also want to have Redux or Flow or Mutable.js. And pretty soon you've built your own patchwork nightmare that, it's not like anyone else's patchwork nightmare, but it's yours. So I really like this more civilized approach of using Elm, which combines a lot of those things into one cohesive language that was actually designed for what it's used for. I feel like Elm has this really good cohesion with Elixir because it offers pure functions and managed side effects with commands. It also has pattern matching, which adds to the familiarity. And the Elm architecture mirrors the OTP architecture in my mind, because the Elm runtime basically passes your update function, your current state, and a message, and you just need to give it a new state, and also your side effect management data of commands and subscriptions. And that looks a lot to me like OTP Gen Server, where it gives you the state, it gives you the message, you give it the new state, and then your side effects are just managed by the beam, the thing you're actually trying to do there. I feel like Elm has this good cohesion with Nerves as well, because it has efficient DOM updates, which for standard front-end development, you want to have performant websites, but when you're on an embedded system, you only have half a gig of RAM and your processor's not very fast. It actually matters a ton. And then also, no runtime exceptions is one of the things that they advertise in the Elm ecosystem. I put probably up there just because I have an ops background, and I can't say no runtime exceptions without a probably there. But if you have an embedded device that you don't have physical access to easily, or you have so many of them that you can't upload all the logs of crashes and stuff, this is a good thing to have. You can sleep well at night knowing that there probably just aren't any exceptions, and don't worry about it. The other thing about Elm is that it really cares about you as a developer. One of my favorite things is the coaching compiler here that they have. I've just written a simple type here with an action. This is for a counter, where you can increment it or decrement it or reset it. And then you'll probably notice at the bottom that I have increment and decrement, but no reset. So what does the compiler tell me? It says, you don't have cases for all your branches. You probably should add a reset, and you should probably put it right here. And here's the docs if you don't understand why that is. And if you don't like the docs, you should change them. So like, that's great, right? That's very helpful to somebody who's trying to get started. The other thing that Elm likes, demonstrates that it cares about you, there's side effect-free packages, it just means that when you install a package in Elm, it downloads stuff to your computer, and that's it. Which, surprise, that isn't true for most package managers. They usually can run install scripts or do other things. And then also, Elm packages are semver enforced, which as a package maintainer maybe is annoying, but as a user of a package, it's nice to know that if something has changed in the API that's going to break your app, they won't let you push a new version without incrementing the major version number. And then this is an example of how the package management system works, where you say you want to install the Elm-Lang HTML package. It says, here's what my plan is. Do you approve? That's a step we don't usually have, isn't it? And then you hit yes, and then it starts downloading things, and it's just civilized, right? Like, I don't know how to explain it. You should try it. I obviously don't have a ton of time to talk about all the details of Elm, but I wanted to point you to a couple of presentations. Jessica Kerr has done several presentations actually about Elm, and they're all amazing. You should check them out. Tomas Koal gave a presentation about Elixir and Elm together, which is really good too. And then I would be remiss if I didn't mention Richard Fellman is using Elm in production at No Red Ink, and he has tons of good presentations about that. So just to wrap up, I want you to think about what FullStack system means for your company. I want you to optimize for small teams with transferable skills and make your systems functional in both definitions of the word. And that's my presentation. No, actually, funny story about the diagrams that I have in here. I drew them all on my iPhone with my finger using Adobe Sketch. So if you need to do that, it's pretty easy.
But that's super helpful. Like I've tried to understand the stack, the nerves, the different breakdown of like what piece is what in nerves. That's pretty helpful, I think.
Yeah. Yeah, I'll have to decide if like maybe this isn't the official rendition of the thing, but
I mean,
it might be worth actually, drawing it with some boxes and text and stuff. Cool. Any other thoughts, questions, or anything?
I would just say that this is seeing the proto versions of this and then the final version. This is awesome. Like it's very polished. You did an awesome job.
Yeah, it actually, if you can imagine, it went way better at the actual conference where I had time to prepare instead of working all day and then showing up here to do it. But
you did a really good job of like moving through it and like presenting it. Good job.
Yeah, thanks.
Anybody else have any other questions for Greg before we move on?
Can you talk about what sort of embedded stuff you're doing at Lito, or is it has to be?
So I guess the question was, what kind of embedded stuff are we doing at Latote, being that we're a women's clothing rental company. So in the warehouse, our business model is that most of our clothing gets returned because it's a rental subscription. So we have to like scan them in, like make sure that we got the thing back that was sent out, send it through cleaning, track it, make sure we know what's in the warehouse, where it is, and then have people be able to pull it to ship it back out to someone. So basically we use Elixir and Phoenix and Nerves for all of that stuff, and then React for the front-end kiosk consoles. So basically just, we're using Nerves devices for barcode scanners and RFID scanners and various other things that we need to do the process. And I guess the reason for that was that we found that the commercial solutions for just literally buying the RFID hardware was, 3 or 4 times as expensive as just buying the hardware without the software and everything included. So, yeah. And it's also more flexible, I guess, when you have control of the full stack, like I was talking about. We can tweak the way that our stuff works, which is a blessing and a curse. I mean, you have to figure out how RFID works, which is hard. But once you've figured it out, then you can be a lot more flexible with how you use it and what you're doing with it.
Yeah, the blessing is you get to decide. The curse is you have to decide.
Yeah, you have to decide. Yeah.
So what we had planned for the rest of the evening is to, open mic, come up, show us what you've been doing with Elixir, and if you have questions or you have problems, let's all chip in as a group and try to help, right? So I think we have at least one other demo lined up, which we could do now. Do you want? Cool. this is going to be about working with Elixir and the blockchain, right? That's awesome. Very cool.
So how do I hook up here?
What's your preferred?
Here you got HDMI.
HDMI is the easiest. Yeah.
Yeah.
There you go.
Is HDMI?
And where is my HDMI?
It's streaming right now. Do you mind if it continues, or?
I don't care.
Okay.
I'll never see these people again. Well, funny story about that. Sad story about that. A year and a half ago, when I started looking at the blockchain, I'm going to make some more mic noise first. That's a lot of fun. Anyway, a year and a half ago, when I started looking at the blockchain, Bitcoin was $400 a Bitcoin. No way I was going to pay $400 for a Bitcoin. I should have hocked my house. But anyway, I digress. So I'm Ken Baum. I work at Engage Partners and been playing with Elixir for about a year now. Off and on, you know how it goes. Still really a noob here, so this is really terrifying standing in front of you people. So if I can hide that, I wish I had Elle here to help me out. But anyway, I've got, I don't have any fancy iPod hand-drawn presentations. I've got more boring stuff, but that's okay. It fits my personality. Okay, so first of all, I want to know, is everybody familiar with the blockchain? Everybody familiar with blocks and Bitcoin? Anybody not? Okay, all right. I've got really 5 minutes, a 5-minute introduction. I gave this at the .NET user group for an hour and a half, so I've condensed it down to 5 minutes, all right? But what the blockchain is it's a ledger, okay? You'll hear people talk about it as a database. You'll hear people talk about it as an event log or something like that. And it's got similarities to all of those. But what it really is a ledger. And if you think of the big green binders that accountants used to use, I don't know, probably too young for that, but some of you might remember that they were, all the financial transactions were written in these ledgers by accountants by hand in ink, okay, so that they couldn't be erased, or erasures would be obvious. So it's an open ledger, and you might not have known this, but if you look at the blockchain, you can look at all the Bitcoin transactions that have ever been in plain text. None of it's encrypted. It's all just out there. So it's very open. It's distributed. Greg, where's Greg? Is he still here? There he is. Your diagram of the communication diagram with 6 or 8 people and all the lines going across, that reminded me of the Bitcoin network. It's a peer-to-peer network. Everybody's connected to everybody, theoretically, okay? So it's distributed. In fact, every Bitcoin node has a copy of every Bitcoin block. So they have all the Bitcoin transactions. Everybody's got them. So it's completely distributed. It's decentralized. You don't need a user ID or a password. You don't go to a third party to get permission to join the network. You don't. When you buy something, you don't go through an intermediary. Okay, it's kind of like Craigslist on steroids. And it's tamper-proof. Now I use the word tamper-proof. It's not tamper-proof, but I can't think of an unawkward. Unawkward is an awkward word. Think about that. way of saying a tamper evident. You know, if somebody messes with it, you know it's going to happen. It's like having dye in your bundles of bills, right? For a bank robber, you know when someone has stolen it. And the way that's done is by cryptography, okay? By cryptographic hashes. We'll talk a little bit about hashes tonight, which is by far the most interesting topic we could talk about, but not much. We won't talk about it much. Looking at the Bitcoin block structure, it's really hard to condense this. The block structure, a block is just a collection of transactions. Okay, so it's a familiar concept to us in computer science. Instead of sending stuff over one at a time, you gather a bunch together and send it over in a bundle. These Bitcoin miners, you've probably heard of Bitcoin miners, gather these transactions, like if I buy something from Matt or do some transaction, trade some Bitcoin, then it puts a transaction out on the network. Miners gather it together in blocks, and then they put the blocks back out on the network. Again, the interesting part is how that happens, but we won't be talking about that. So the structure, and what's relevant for me in writing this parser is that the blocks are delimited. The whole structure is in files. It's a flat file system. So there's dozens of files with hundreds of blocks in them, containing thousands of transactions. So a parser is going to have to open up all these files and pull out all these blocks. That's where I was having real trouble. So they have this magic number, this hex number, D9, B4, BEF9, that is the block delimiter. It's a sentinel value, basically. When you read that, then you know that the next 4 bytes is going to be how long the block is. The next 80 bytes is going to be the block header, and the rest of the block is the list of transactions. Okay. Now, the documentation says that there are blocks that don't start with that sentinel number, which really screws me. Okay, but I haven't found any that don't, and I don't really care about that right now, because right now, when I first here, let me show you something. When I first started this project, here's what I thought. Here's what I had in mind, was something like, okay, I'm not connected to the network here, but this is a block explorer, blockexplorer.com. You can look at any block in the blockchain, and if you go back to the home page, I'm not connected right now, and I won't take the time to do that, but it'll just, as the transactions come in over the wire, it'll list them, right? As the blocks are mined, and it'll tell you who mined them. And 70% of the blocks are mined by Chinese mining pools. Okay, that's just statistics. That's what I wanted to build. Oh, that was stupid. That was dumb. That was way too ambitious. So let's go back to this. So I'm going to be happy if I'm just able to read in a few blocks and parse the header. That's what I'm going to be happy with, okay? And then maybe figure out something, some other way to do it, or some more to do. Okay, so the block header, these 80 bytes consists of a block version, which for a long time, many years, was just one, first version. It's just a version of the blockchain. There's a 32 bytes that contains a hash of the previous block header. We'll talk about that in a minute. 32 bytes, that's a Merkle root, okay? And I'll briefly describe that, although I won't be able to do it justice. There's a block time that's virtually not used. There's 4 bytes, that's this n bits, that is the level of difficulty. Miners have to solve a cryptographically difficult puzzle to mine a block. If you didn't have this, then everybody could mine a block and you'd just flood the network with blocks that had all kinds of different transactions in it, and it would be chaos. So they have this puzzle that you have to solve, and statistically it's a probabilistic algorithm. Statistically, every 10 minutes a block is mined. Every 2 weeks they adjust that difficulty. If it's been over 10 minutes, they make it easier, for the previous 2 weeks. If it's under 10 minutes, they make it more difficult. So it's dynamically adjusted in the software. This is all done programmatically. And it's way cool. And there's a nonce. Nonce is a cryptographic term for just a random number that you try. Will this number solve the puzzle? Well, let's try this one. How about this one? You just pick one. And since it's a probabilistic algorithm, you have just as good a chance of starting at 1 and just incrementing by 1 as starting anywhere else. If you don't really see how that is, then you probably played the lottery. It's just probabilities. Originally you could mine lots of blocks on this guy. Now the average time one of these laptops would take to statistically would be like 200 or 300 years. They have the hardware just keeps growing and growing, and they burn the algorithm into chips now to make it faster. All right, that was fun. Okay, so this is a blockchain. I just threw this, I had this from my previous presentation. I just threw these bodies in here, so it's just where the transactions are. So this is the header, this is the body. So you have 80 bytes, and we just went through what those bytes were, the version, the hash of the previous block, etc. So down here you have the Genesis block, which was the first one that Satoshi Nakamoto, or whatever his name is, Satoshi Nakamoto, mined in 2009, which is the one we'll look at. And then on down, this is just everything that's happened in between. So you have in the header, you have the hash of the previous block. Now let's go down here because we've got a previous block. So let's say that number, and it's a truncated number, is the hash of the 80-bit header of the previous block. Now, that Merkle root I told you about is a hash of all the transactions, and it's a special structure. It's called a hash tree. It's just a binary tree with the transactions are the leaves, and then you complete hashes all the way up to come up with what is called the Merkle root. Merkle was the name of the guy that developed this. So that's up there as well. So theoretically, if you tamper with this, if I say, hey, Paul is sending 100 Bitcoin to Matt, and that's $110,000. I'd really like that. I'll have him send it to me. So when the miners or the Bitcoin nodes process these blocks, they complete the hash. The Merkle root's going to be different, which means this hash is going to be different, which means this hash is going to be different, which means this hash is going to be different. You'd have to rewrite the whole blockchain in order to take it over, pretty much. And the reason that's highly improbable is that you got this guy up here. He's the head. But H doesn't stand for head, he stands for hash. He's the hash of the current block. And he's in memory. He's on my machine. You can't have it. You can't get to it. So it's going to be evident to anyone if fraud is committed. Okay. So that's just a very, very quick talk about the blockchain, and I'm very sad that we don't have more time to talk about that. But let's talk about my shitty code. I have, I have in my Elixir project here, I've got a over here, if you can see where the mouse pointer is at, I've got a folder called blocks. Elsewhere on my computer, I've got, in fact, I have a path to it. I don't have the whole blockchain because it just takes up too much disk space. It's about 50 gig now. If you plug in a node, Bitcoin node, in now on a Virgin machine, it'll take about a week probably to download all the blocks to get it up to speed. It takes forever. So anyway, so I've only got one block here. And this is what it looks like in hex. And, you know, this is, if you look here, this is the first 4 bytes. And you'll notice that it looks very similar to that Sentinel value, only it's backwards, isn't it? Yeah, it's a little endian. So you have to read it in that way, or you don't, or you'll, well, that way madness lies, you know, if you don't do that. So you have the Sentinel value. The next 4 bytes is the block size. Now this is the Genesis block, which I always thought that was such a cheesy name, but that's what they call it. The first block. So it's only got a size of 011 delta, which is 285 bytes. Okay. After that, you have a version number that's 4 bytes, and then you have your hash. Now, the hash of the first, there's no previous block, so your previous block hash is 0. And then down here, you have your Merkle root. Okay. So it's just a bunch of binary gobbledygook, and you say, well, Ken, you said it was plain text. Well, it is. Just to show off for us, Mr. Nakamoto put the times, the date, 3 January 2009, and the headlines from the London Times in the transaction, or in the transaction. So I've heard, I haven't seen it myself, but there's allegedly some really wild stuff in that people put in. You can put, you know, if you put, it's kind of like putting a notice in the classified ads that from this day on, I'll be responsible for my own debts, you know, something like that, some kind of disclaimer. You can do that. People use the blockchain for that. It's legal proof that they knew something at that point, because that's the only way it could have made it into the blockchain. So people do all kinds of silly stuff with it. But, you know, that's where innovation comes from, right? That's where smart contracts came from. That's where a lot of the uses of the blockchain that aren't cyber currency have come from. Okay, now let's go back to my parser here. So I've got, I don't know, can you see that well enough? Yeah. Let me close this guy, give a little more. Can you see it, Paul? Yeah. All right. So it really starts right here. I've got a method called, or a function called runH. That's just, at some point I said, well, I'm just going to be happy if I can read a damn header in, okay? So I run header. Plus, you know, I could, if I was to really do this, I would probably want to put the data in a database or something, because just reading it into memory is just, you know, I've got some C# code that does that, and, you know, I blow out memory really fast. So anyway, so I've got a function called read blocks dir, where I just go and get my directory, and then I go to process block files, and I go into this for loop here to consider each of the files. Someday I hope to get to the second file, okay? And I call this function called strip sentinel, which all it does is pull the, since it's a binary stream, I use binary matching, which that took me forever to figure out. You know, it takes a long time for some reason to realize when it says right side doesn't match, that it doesn't match. You know, that it really doesn't match. You know, and you think you're doing something else wrong. No, you're not where you think you are. Anyway, so strip the sentinel off, and then I call this process block file, which is down here. And now this is all I have right now. I read in this the block size, and that was another, Matt was with me in some of these travails about why isn't it reading the right block size? Or why isn't it getting to the end of the block? And I didn't realize at the time, and the documentation is less than great, that you have your sentinel value, you have your block size, then you have your block header. I was considering block size as part of the block header, and that didn't work. So I'm using Little Endian. I read in 32 bits, okay, which is the block size right there. And then I use the block size to read in the block, all right? And then I have the rest of it that I hope to do something with someday. So then, and I take my block, which is over here, and read in the version number, the previous hash, the Merkle root, and then the rest of it. And then I just print it out. That's all I'm doing. Okay. So my question and my struggle is, how do I want to be able to eventually at least get to the part where I compute the hashes and compare a hash to what's supposed to be there. The hashes are SHA-256, and for some reason, when Satoshi initially wrote the C++ code, he hashes it twice. It's a hash of a hash. I think he thought that was more secure. I don't know. I'm not sure it is, but some people think it is, some people think it isn't. But anyway, I need to be able to do that. The problem is, and this is my output down here. Of course, it's not in hex. I would like to put it out in hex so I can understand it a little better. This is the previous hash, which for block, the Genesis block is 0. And this is the Merkle root. And I went out to my block explorer and verified, found an online hex to decimal converter and verified that that's the right value. And then this is the rest of the block, which is all the transactions. I'd eventually also like to get to the transactions sometime, but right now I'm still fuzzy on how to go through this loop. How do I, because I need the next block in order to compare the hash in the next block to the hash from the previous, by hashing the previous block, right? Let me see if I can say that a little more, in a little more awkward way. The file starts at the top with the oldest block. I got to read all the way to the bottom and work backwards. How do you do that in Elixir? And not only that, I've got 100 of these files, so I need to read all the way to the bottom of this one and work all the way back. Which maybe if I do store it in a database as I go along, see, I'm thinking of stuff as I'm on the fly here, and that way I just read it as it comes in, and then I can work backwards once it's in the database, because the yeah.
Right. So explain the issue again about reading backwards.
Well, wish I had something to draw.
There's a whiteboard right there.
So we'll come close. Can they still see me? So I've got Unicorn Office. I've got. You sure? Okay. All right, so let me get over here since I'm right-handed. Let's say you have BLK 000050.dat. First file. So you got block 0 here. You got block 1 here. You got block 2 here. You got block n down here. So I'm reading it in from this direction, but I need to compute the hash of this header and compare it to the value that's in this header. So I need to go. I need to read it all in first. Or at least this far. Maybe I just read 2 blocks in.
I was going to say, how do you know when you're at the end?
I have my block size.
All right.
So I read up to my block size, and then I do the same thing again. I have this sentinel value. I can't remember what it is now. That's, yeah, whatever it is. Some sentinel value, right? So and theoretically, okay, with the block size, that puts me right at the next sentinel value. So if I try to match on it, it should match. Again, I've read in the documentation, I've read that there's not always a sentinel value, and then I don't know what I do in that case. I don't know how to read until I find one. Just do it 2 at a time, just like a look ahead.
It doesn't match, right? So you get to block 1.
Yeah, and so this guy, yeah, I'd have a hash. This is the hash that was computed, that's in the blockchain. Then I'd computed a computed hash here that's from this guy. Pardon? Yeah.
Verify block 1, verify block 2, or whatever. You don't have to store anything in memory. You can just do it.
Yeah.
It's starting at block 0, you know how far you need to read until, is it until the end of the block or to the end of the next sentinel value?
End of the block. The next value I read should be the sentinel value after I've read the block in. Mm-hmm.
right? And then at initialization, it begins to read and goes through until it hits that size. Once it hits that size, you know, it's doing a map, right? Once it hits that size, that is the product, right? And then you can send that off to compute hash process or whatever, right?
Yeah.
And it grabs the next one, so you have like a gen stage.
Yeah. Because I would need the whole hash, the whole header to compute the hash, but then I'd need to go inside the header to get the previous hash.
So there's probably a function that you could chunk the file into blocks is one thing you could do, is to say like, you know, print out whatever the block says it has in it as a first step. And then
Yeah.
from there, you could try to compute the hash on the structure that you have more.
I wanted to do that in the worst way, and I just couldn't figure out until I figured out that epiphany I had with Matt. I think I can do it now, but this stuff I just got working last night, so this is hot off the presses.
I feel like one key realization is that this binary that you're working with is actually the same thing as a string, so you can use all the string module functions on it, like find the magic string.
Yeah, working with binary was a little painful. That might be a little easier. I don't know. But again, the nice thing about binary is I handle the little endian problem pretty simply. So that was another revelation right there when I found that the little dash size. You know, that's nice.
Yeah, I didn't know about the little size. That's super.
Yeah. Okay, well, I don't want to take up everybody's time, but just you can noodle on it, and if you think of something.
My first observation is some of the matching you're doing there.
Yeah.
You could actually break those into multiple functions, smaller functions.
Yeah. Okay.
And then put that match actually in the head of the function.
Well, I saw that in Greg's code tonight, and I thought I need to do that. Yeah, that's cool.
That might help break up the problem.
Yeah. Yeah.
But the other thing I would say is, like, it sounds like this is a perfect fit for Gen Stage, because you like Greg said, you had an operation where if you could chunk the whole thing in chunks of 2 free ahead of time, so now you have your producer, right? You have your first producer consumer that chunks it, and then you hand it off to the next consumer that starts reading.
Yeah.
It seems like the problem fits that flow.
Just the size of
Maybe flow. Yeah.
Just the size of the block vary. I mean, it's the overall.
The size of the block varies. Now, the max of all these is the maximum it can be is a megabyte.
That's right. So the initial chunking, I thought you could chunk the whole thing in 2s, and then that way you could read 2 bytes. Another process reads 2 bytes in and knows whether it needs to keep reading or not. Yeah, the block header. Yeah, that's the length of the block.
But you would have to read the block header in order to chunk it.
The first, yeah, that would be the first.
I see.
Well, the block size is before the header, though. That was my big problem. You have the sentinel value, the block size, then the block header, then the block body. So I know how much to read, and if I'd have had this realization about a month ago, I'd have a lot more to show you tonight. But
That's still really cool. I really appreciate your introduction, because I've been meaning to really dive into some of that.
Yeah.
And like this is like, oh, that's what I needed.
yeah.
So
Yeah, the cryptography is really cool. I really like the way it enforces the openness. You can look at it, but you can't change it. Not without getting found out. I mean, they call it the 51% attack, where if you controlled 51% of the resources on the network, it's actually statistically a little less than that, maybe around 45%. But and if all the mining pools in China got together, we'd be screwed. Not we, whoever owns Bitcoin would be screwed. But they seem to be just content to mine everything, and they're not interested in fraudulent wealth when it's just easy for them to get it legally,
I saw a tweet today that like the energy usage of Bitcoin mining is now equivalent to the energy usage of Denmark.
Yeah. It's nuts. I saw there was somebody that was trying to market a lamp that was a Bitcoin that was powering a lamp from his Bitcoin mining rig, trying to reuse some of that power. Yeah, and there's clearly in my mind a moral issue with some of this stuff, because just the waste of power is. If you look at some of the warehouses full of these mining rigs over in like Sweden or in China, it's just nuts. Hundreds of thousands of these guys. I mean, they must from space. It just must look like a red glow, All right. Any other questions or anything? Thanks for all your help. I appreciate it. Appreciate the time.
Yeah, my son is actually really upset about that. Because the graphics card he wants apparently is like the mining. The hot one. Yeah, and so it's like $600 because of that.
Well, what you want is last year's mining card.
Yeah.
No, like basically free.
Well, there's also, there's that, because there's like a generation ago is better than the most recent or something, and it's actually higher, like, because of that, the price is MSRP cheaper, but you can't find it for MSRP because everybody marks it up to the market rate. I keep forgetting I should use the mic. So thank you very much for that. That was really good. It was a good introduction to Bitcoin. It's got my head spinning around some of the smart contract stuff and like the blockchain as database. Really super interested in seeing where you end up next month. So come back, show us. I was also curious if we have more demos.
I have something I want to show. I
Yeah.
have some commentary on Bitcoin.
Oh, okay.
So with healthcare,
All right. 'Cause I don't want to drop the mic. Yeah.
So we've been doing a lot of healthcare stuff, and not Bitcoin, blockchain is a big. I don't know if you've even looked at any of that, but it's this emerging thing within the healthcare space on these contracts, and the idea is how can we securely trade personal health information across health providers and be able to set up these contracts, thinking of EMRs and patient records and all this data that nobody wants to share. How can you securely trade that information between two people? And so there's a lot of movement around what that looks like. Yeah, and whether it's the open text part, it's so I don't know exactly on the level that Ken was talking about, but it's the generic model is I want to share my information with you, or your insurance provider, and you're going to you're going to charge me $20 or thousands of dollars for whatever, and how can we securely, how can you say that's my transaction, and then how can I say that, yes, I approve that you're making these transactions based on some of the things that I'm up to. All right. So the stuff I'm up to isn't really near as fun as the blockchain things. But really what I wanted to see is whether my brain is working in a functional way. So I have a couple of things I just wanted to show you guys. Great. All right. So I have this concept. This is just an experiment. There's no real need for this, or so maybe some background is my dad is really into stock trading, so he's got all these models that he researches and looks at, and he's retired, so this is kind of his thing. So I said, it would be really cool if I could take one of your models and see if I could do it in a functional language, in Elixir. So he put some of these together here. In one of these things, I have the rules. I don't know. Can you see that okay? Better or worse? All right. So this part is not really important. It's just I want to just see if I'm running through this in the right way. And kind of to Ken's point, what I have is very simple, but it took me a long time to get it to that spot. So the idea is, as I'm evaluating a stock, I'm going to make decisions on whether to buy more of it or to sell portions of it. So I'm going to make two purchases. One is half the amount. Say I'm going to spend $1,000. So one will be for $500. The next one will be for another $500. I won't buy my second position until I've at least made a 2% profit on my first one. And then if I go down at any point in time, 7%, then I'm going to start rolling back my positions. And then if any of my positions is up 20%, then I'm going to cash out. It's basically the kind of the model. So what I ended up with, and maybe I should show you my tests first here, but
yeah, I was going to say, that sounds like test cases.
yes, very much so. So what I ended up doing was saying, what are signals that I could get based on positions? So if my position has a greater than 7% loss, then what's the signal that I'm going to set? So a sell for loss signal is set to true, and that percentage change is 1. So I was telling Ed as we were walking in, when I first, my lesson learned, I think, is that it's data transformation, right? And because when I started, I'm thinking, oh, cool, I'll have a stock class, and it's going to be able to, it's going to have these behaviors, right? And then it's going to know what this looks like and what that looks like. And when I first started, I was even going down the path where position 1 or position 2 had to know about position 1 and to ask it, right? If you were down 5%, then I'll sell myself. That's kind of how I was thinking. And so it's evolved to now where a position is just a position, and all I do is I pass in its purchase price and its closing price, and then the process itself can tell me what it knows about based on the model, right? It knows whether that's a sell position or a purchase position based on that percentage. Does that make sense? So anyway, I have these tests here, which are taking in a purchase price, a closing price. It's basically understanding that percentage change in order to evaluate a signal, which in these cases are cells. Does that make sense so far? Sort of.
Yeah, so signal is what kind of data structure?
So yeah, so I also started with those. This was another thing that evolved, which was I had this whole thing, and this has gotten much simpler, and where now I'm just saying, just give me 4 signals and my percentage change, and let the processor use percentage change to tell you what to do next. And then it just goes back to the originating processor to figure out what to do on other positions. So I know I'm doing a brain dump into this domain, but that is basically made up. So this is what my code looks like. And this is what I'm curious. So it sounds like the way I'm thinking with the data transformation and the processes seems correct based on you saying, sort of. So then I'm wondering, because now I'm entering into these default patterns for me, which is taking this struct, right, and basically piping it through all these data transformations in order to get my data back, my signals back, my processing through. And so with all the other things that I've been up to Elixir-wise, I'm ending up with a similar set of patterns. So I'm wondering if it's just because it's my pattern that I understand, because I've kind of come to this understanding of how I should use this, or whether this is kind of a trap and I shouldn't be thinking about. I guess my first question is, does this even make sense from a Elixir functional perspective?
Yeah, I think so. Let me see if I understand this. That struct is just the data with the percentage change, and each of those is kind of a maybe in that it maybe sets the cell for loss signal, or maybe sets the by next position signal, or maybe sets the cell
Yes.
for profit signal.
Right, yep, just piping it through, yes.
So you could store each of those as a function and then just map each of those functions in a list and then just map over each of those functions on the data. That could be another way of doing that. Is it a thing I'm thinking?
So that would be the pattern where we have the atom, and then it's matching on the functions that way.
I was literally thinking you like store a list of the different signals that are functions, and they all take the same data structure, which is that percentage change.
Mm-hmm.
Or well, actually, it's the stock position, calcium active signals, and then percentage change is the second argument, right? So what you could do then is just have a generic kind of, that way it becomes a little easier to add. You could separate out the functions, the signals from the data a little bit,
Mm-hmm.
and it makes it easier to add more signals later.
Yeah, so that's also, yeah, right. So that's my other question, is if I was to add another signal, I would just pipe another thing.
Right now,
Yeah. So you're saying if it was just more functional,
it's
or,
just another way of organizing the code. Really.
yeah.
I think you're doing the same exact thing, you're just organizing it differently.
Are you? Yeah, this is something. Percentage change.
Yeah.
Is that in the struct and an argument?
No, it's up here. So the idea is,
I'm talking about like lines 24 through 27.
Yeah. So yeah, 24. Your
It looks like
pattern matching.
to me, but maybe I'm.
yeah, so the idea was that this would be the process that would evaluate based on a purchase price and closing price. and then it's going to determine a percentage change, and then I pat whether this is right or wrong, I don't know. So that is something I'm using in the struct. Might be just part of refactoring noise, maybe.
Yeah, so I think the point he's making is that that percentage change is already a part of the struct that you're passing into those functions as the first argument, so you don't even need to pass it in as a second argument there. You can just get rid of that second argument entirely.
Mm-hmm.
You could destructure it if you just wanted to let the percentage change.
Yes. Yeah, no, that makes sense. Yes. Yeah.
Yeah, so then each of those functions would do each.
So let me step back just one step. So that's basically where I've stopped. But the idea is that I have the ledger of stock prices and stocks, and then I would run through those and passing the purchase price and closing price into this process, and it would evaluate a bunch of different stocks all at one time, with the idea that I could give it information, stock price information, and as many stocks as I wanted. This thing would evaluate them and then come back and give me stock signals for each one of those things. So there's a process on top of this, which is a list of things, stocks, and their historical prices, and feed these in so I could get signals from them, for it to tell me, based on the model, what it would look like, what things I should do.
Your different signals appear to conflict, right? You can't have multiple set to true, for example.
Right, no, that's right, yes.
So there could really be one value that has an atom value and match on that, as opposed to having 4 different fields which are true or false.
Yeah, I guess that's what I was thinking a little bit on top of what James was saying. Is that what, so here there would be an atom down here, right?
You could just have a what should I do function that will return an atom of what you should do.
Yeah.
And then somehow make magic happen in between each atom.
Yeah, okay. Yeah.
It could be really fun because you could log it and then be like, buy, sell, no.
Yeah, it could be more interactive. Yeah, and so then that would just mean refactoring these, right? And then the way that these things get called is just a pattern match right up here, right? Based on the signal. Is that me?
Sorry.
Is that the right way of thinking of that? Or is it still another layer up? Does that make sense, what I'm asking? So if each one of these functions could match on what I was up to, right, with the atom, is it just a matter of refactoring these and?
Oh, actually, yeah, you could totally make most of that guard and then have multiple percentage change functions.
Yeah. Or each of those little algorithms comes out with a value.
Yeah.
And functions that match the results of those values.
Yeah.
Is that all within the same process? Or is that one process and then I now have another process feeding those things in?
Yeah.
Well, I guess I was thinking of this as a process. Is that the right way of thinking of it?
This is just a module, so it's running in a single process wherever you're calling it, right?
Mm-hmm.
If you wanted to break it out into its own process, you would have like a decisionator process that is like a gen server that receives a stock and then calls a strategy on that stock or something, and then outputs the result of the signal, like buy, sell, you know what I mean? Like,
If you're just processing an input file, you need a process.
yeah.
That's just for asynchronous state tracking.
Yeah.
If you wanted to do like a parallel map, like if you have all of the stocks and you want to parallel map over all of the stocks and call this
Yeah, that's kind of what I had in my head. Whether
Yeah. Or like say it's a stream, it would make sense to have like thing for each stock that you're just it's continuously evaluating whatever updates.
Yeah. So you
It
have
always comes back
you have
to
you have a producer, and then you have like several consumers that process.
and then so that's all still within a gen server.
Well, what we were just talking about would be like gen stage, so you'd have stages of doing.
Oh, the gen stage stuff.
But the parallel map, I don't even think you need a gen server for that. If it's a finite amount of work,
Mm-hmm.
right?
Yes.
And you just want to kick it off and say,
Yeah.
concurrently calculate what I should do and
Yes.
return me a map of decisions.
Yes.
Then that's still just a module that spawns some tasks or something. I would use tasks for this since it's like pure copy.
Yeah. Okay.
There's no state. It's pure.
Yeah, so that was actually one of my other kind of self-constraints was I wanted to prevent myself from thinking state. Because going back to how I was originally thinking, I was thinking state, and then I was thinking gen server, and what does this look like? And so that was were my initial thoughts a long time ago. So I kind of told myself, I don't want state, because I think I can do this without state, and then that will force me into thinking of it differently. So it doesn't mean that I couldn't introduce state now that I'm kind of in that mode, but
State is just a data structure that you pass around, so it's perfectly valid.
yeah,
A very common functional pattern to have state going through functions. It's just not encapsulated
Yeah.
inside the.
just as long as I don't abuse the word state. So yeah,
But
yeah,
you could imagine even with a process that's doing this over a list of stock prices coming in.
yeah,
That maybe down the line you have a model where you want to look back more
Yep.
than two prices.
yes, right, yeah,
Passing some additional state.
yeah, okay.
You would have the history, you would pass around like the history for that specific stock or something. I'm just kind of thinking about like,
Yeah, so in that case, could use the, wherever I was here, the more functional, what's the right way of saying that? Functional matching with the atom, or what?
I just call it function matching or
So,
function pattern matching.
so that could probably streamline more of what I've got, or maybe even make it in a little clearer from a functional perspective, right? How I should be calling these things. And then maybe the next step would be the introduction of the gen server on the other side, the part I haven't done yet, which is then trying to push in a bunch of data so that it can process a lot of things and give me a lot of signals.
Yeah, well, I think you can do the parallel map right now as you have it, to be honest. Like, in that evaluate, for instance, like if you have a list of,
What is?
if you have a list of stocks, I don't know where you have that now, you could call your strategy in parallel just by saying, like, map and then spawn a task for each one, right? And then call weight at the end of the map, right?
So is that something what you're using the term parallel map, or what did you say?
Yeah, it's essentially a parallel map. I don't know if it's actually parallel, though. It's not really guaranteed to be parallel, but.
But is that something I could type in and understand what that means?
So if that's what you want to do, you probably want to use the task async stream function, which does that for you. But I would say get it working the way you want serially first, and don't worry about parallel anything or
Yeah.
other gen servers. Just get it working the way you want. It's very easy to optimize it to do things in parallel.
Yeah.
Once you have the structure in place.
Yeah, okay, that makes sense. All right, cool. Cool.
And map just takes a function and applies it over a list. So that's just a way of saying, like,
Okay.
And then parallel map is just something that takes advantage of like Erlang processes and your
Okay. Yeah, that's good.
multi-cores so that
Yeah.
you just type pmap and it's exactly the same API as map, except you say pmap and
Okay.
it takes better advantage of your hardware.
Okay. All right. Yeah, thanks. That helps. Okay, cool. So that's my 20 lines of code or whatever it was.
This part, can you scroll down a little? This percentage change, self-for loss, and all of that.
Mm-hmm.
If that is like all your formulas and it solves all of your problems, I do think you could make that one function and then make that part of your guard. Am I wrong? Is there something not guard?
If you don't mind me typing on my computer, I can try it.
Yeah.
I do think
Are you up for that?
Yeah, that would be cool.
It would be harder for me to get it figured out on my computer. So I think what.
Yeah, I think about like, and then I think about like data transformation, like transform purchase price and stock price into a certain rate. Yeah. I mean, but if it's one function, all you have to do is return the signal for the match, right? Yeah.
This has the percent change in it actually, right? Too.
Mm-hmm. Yeah.
Then use guards to do the right signal. Yeah.
Yeah, so this is just gonna be pulling out the change. And then you can just do when change, what is the rule on this one?
So you have closing price and purchase price.
This is maybe a bad example to start with because it's more complicated, but.
Less than or equal to negative 0.7.
But the,
That's the.
Not a strategy, that's like a utility.
Yes, that's
oh,
right.
Yeah, so I'm trying to implement this on something that doesn't exist.
Yeah, it would be the one underneath it.
It helps to read the code before you start typing. Turns out. So active signals is either a map or a struct. It's a struct, right?
Mm-hmm.
So that also functions as a map, but active signals is going to have a percent change in it, I think. We
Yes.
decided like this isn't actually needed, the second argument. But then when change is less than or equal to negative 0.7. See, that's how you lose $1 million right there.
The old office space.
Yeah.
So basically, like that's the whole function head for that first one is like that, and then you just make another what to do for each of these things, and then you just call what to do with your active signal, and it just like you can reorder them. It'll evaluate whichever one matches first. Which I guess in this case only one would ever match because you're going to have different brackets of
Yeah.
stuff.
Yeah. No, that's cool. I like that.
So then, like basically, you just replace all these functions with a what to do function that has multiple guard clause function heads things, and then you just operate on like this is what you should do when you call that function, and then you'd probably have like a case with a with one of those.
Well, you could, and then all you need to do is enum.map, your list
Mm-hmm.
of the active signal active signals.
Mm-hmm. Yep.
And the function you pass that is your what to do. And since it's pattern matching,
Yeah.
it'll know which. And then
It'll find which one what to do.
Yeah, then what you'll get is a list of signals.
Yeah. Cool. That's awesome. I get it.
And you map again.
Yeah. Yeah. Awesome. Yeah. That's good. All right. Cool. I like that.
You probably want to map it into like the position and the what to do.
Yeah.
What in the active signal do you care about? Like, is there like an ID kind of thing?
No, I mean, yeah, it was just my way of holding something so that I could run my algorithm, and then in my head, while I'm visualizing these three things, right, and then I'm seeing different strategies or different models that could implement different signals for loss, for purchase, next position, or whatever. And then these kind of be this could be different models, right? It was just one way of, but yeah, I don't know if there's any real reason for it other than I just wanted a place to hold it.
So one nice thing about doing that multiple function set thing is that like your different models could be 10 or less lines of code when you get done with it, because if they're just
Yeah, definitely. Yeah, this would definitely simplify it for sure. Yeah. Yeah, cool.
And then the what to do, the result of what to do is kind of like an enum type. It's like one of these things.
Mm-hmm.
And so you could maybe, if you wanted to do some like type annotation, there's something called dialyzer where you could say this function gives back one of self or loss by next position or self or profit or whatever.
Yeah. So it's more explicit, you mean?
Yeah.
Yeah. Okay. All right, cool. I like it. That's what I was, yes. Cool. Thanks, because I don't know if this would have taken me a while.
Well, you mentioned the data transformation thing, and the way I'm thinking about it is you're giving it a purchase price and a stock price, and you're transforming that into a signal.
Yes,
You're-
right.
I mean,
Yeah.
that's what
Yep.
that's all this is.
Yes. Yeah, which took me a really long time to get there.
I know.
Yeah. Yeah. Because this is what I was telling Ed when we were walking in, is I just remember Mark Winholz doing it, because I came in the October one, I didn't come last month, where he was just saying, this is my Elixir code. I think I may be thinking of it right, but I'm probably still thinking of it in OO. Because I think that resonates with some of the things I still think about. But it's so much fun to think in this way, and it turns into this puzzle, and then I don't know, it's fun. It's totally different. So.
I think you hit the nail on the head though when you said it's just data transformation.
Yeah. Okay. Good.
That really is the core of it. I don't know. For me, that was the big aha moment when I was learning Elixir and trying to understand functional versus like what I was doing in Ruby. Like the power of data transformation was like, oh man, I feel like I have so much more control. Like,
Mm-hmm.
I know I get in this connection struct, and then whatever happens after that is just data transformation.
Yeah. Yeah. It's a nice isolation. It's a totally different way of thinking of it for sure.
The only other thing I would mention is up above where you call percentage change.
Mm-hmm.
It would be clearer if you just called that instead of pipelining that. Because that took me a second when I was looking at that, like, what's that doing? I
Yeah.
would just say like percentage change versus textbook.
Yeah. Just do this. Yeah.
Yeah, I think that's one of the early things that happens is like you get super into pipes.
Yeah. Well, even doing this, right? There's how many? 4 pipes, and it already feels a little dirty. I'm like, I don't know if this is what I should be doing.
Honestly, that's fine. Like, that kind of, that's what they're for, but like to Paul's
Yeah.
there is when you only have one like that, it's really, you're just like inverting your parameters.
Yeah.
It's a little harder to read.
Yep.
We benefit from some aliases showing up in module names.
Oh, yeah.
What is that?
It's like you alias your stock positions and slim active signals. You can then reference active signals as the primary module in your code.
Is he calling
Oh,
the-
this thing.
Yeah.
So just so it's not this dot chain.
It's rid of the velocity.
Yeah. Right. Got it.
At the top of the file, just say alias, put that module after the alias, and then you can just say active signals.
Okay. Okay.
But to be fair, I think you're only calling it once, right?
Yeah, just in that spot.
So,
Because I'm piping it through everywhere else as an extra parameter. Right?
yeah, so if you wanted to do any pattern matching though, where in the function head you say, percent active signal braces, then you would benefit from throwing it up there.
Yeah, okay. Yeah, that's all good. I like it. All right, cool. Thank you. Greg and Ken didn't get All right, yeah, thanks.
All right. Does anybody else have any code they'd like to show off? Or questions people would like to ask, or anything we can help with while we're all here? Zach looks like he wants to show off his Texas Hold'em engine.
I guess I can just do a quick demo.
Yeah, that'd be awesome. By the way, thank you to everybody who's given demos. Like, super brave to get up and show people your code. And I know both of you have both mentioned, like, it took me a while to get here. I know it's not much code, but that's totally awesome. Like, that's what happens when you're learning, right? Like, so, thanks for demoing.
Do we have a connecty thing for the?
Oh, great.
This microphone here?
You can, either one, it's fine.
Yeah.
Try that, see if that works.
So since we were just kind of talking about how, like when you're new to Elixir, like you see the pipe thing and you just want to do that all over the place. So my actual game engine is, it's a state machine. I use the gen statum module from Erlang. And I have some crazy piping going on in here, and I eventually want to clean this up. So I have like this updater module that just knows how to like change one piece of the room data structure that I keep, which is actually kind of huge. This is my thing. So this kind of keeps track of like what state the game is in. And so I just pipe that through like a ton of transformations as you go through the game. So I actually haven't touched this code in a while. And I've been working on the front end, which is a different project that I have in Elm over here. So I'll just kind of show that off a little bit. So that's same.
Also the Elm meetup group, because there's not an Elm meetup group, so occasionally we talk to them.
Yeah. So there's kind of some stuff that I have Phoenix right there on line 19, if you see that. So that counts as Elixir too, right? Right? So essentially this is like my representation in Elm of that actual room model that I was just showing you in Elixir. So I initialize it with this kind of basic default room. This is my view, which is actually like I have a bunch of other functions that handle view stuff. And it gets a little bit complex. I've got a bunch of update things here. The interesting part with integrating with Phoenix was, so I'm using this library called Phoenix something or other. Let me find it for you. I think it's in my Elm stuff. So there's something weird about this thing that I used where it has some effects, so you can't actually download it with Elm package. Like you just have to clone it from GitHub and just put it into your repo. It does have side effects. I'm actually not sure where it is right now. Let's find it. I think in Elm stuff there's like a manifest of what things you have installed. I have my my brunch config is really weird, so I have Elm stuff like in a bunch of places it shouldn't be. There you go, vendor. That's where it is. Assets Elm vendor. Down here. Phoenix. Yeah. So anyway, this is actually not my code, right? So I just copied that from GitHub. And then in my code itself, right, I import that in. And then I have this phoenix.connect. I have a socket. This is actually a function that takes my session. I'm storing the session in local state. And then I have a model that, in the model, I'm actually holding subscriptions to different channels. So I'm actually connecting to 2 different channels on the client. And let's see. To get that all set up, I have this socket config module, which basically takes care of like actually connecting to the Phoenix channels. So basically, you give it a socket URL to configure it. I pass in the session. That was what I was showing you earlier. And then you pipe it through a few different functions here, right? So when the socket opens in my room model, I get this socket open message, right? So this update function here is a huge kind of case pattern matching statement. So on open socket open right there, I do nothing. So connecting to the socket is really not that interesting. What I was more interested in was like actually connecting to a channel on Phoenix. That's where the room state is actually being held on the server, right? And it's just sending broadcasting update functions over the socket. And then there's a few things that I'm interested in, right? So the server will broadcast these update functions. It'll send me a payload. And then on the Elm side, I'll say, great, I got an update thing, which is over here somewhere. There it is, update payload. And then I have these helper functions to handle the different messages I get. They're in a different file because they're getting really long. But anyway, I want to show you like a little demo of how it actually works. All right, so I don't know why Firefox does this. All right, so I joined over there in Firefox. I'm going to join over here in Chrome now on a different process. Start with 200 chips, right? Let me expand this out because my mobile version is not that great. All right, so now I can like hit the call button. My client's going to send a thing to the Phoenix server. The server's going to go, great, this guy just called the call method or function, and then it's going to do an update, and then it's going to send me back. Sure, yes, because many people probably do not know how to play Texas Hold'em. So I'll give you like a brief kind of rundown. Anyone here played Texas Hold'em before? All right, cool. So a few people know how to play it. That's good. All right, so if you're familiar with the rules of poker at all, so essentially what this is I'll actually explain as we're going along. So what's my guy over here, user guy? No, Zach is up now, right? So I've got an ace and an 8. So an ace is a high card, 2 is a low card. So you can get, let's actually get some more cards on the board.
So call is just saying it's the next person's turn?
Okay, so when you start in Texas Hold'em, there's a thing called blinds. So the first 2 people are expected to pay, like, there's a minimum that you have to pay to get into the first round, right? So there's a big blind and a small blind. The big blind immediately plays the minimum amount to actually get into the first round, right? To begin with, by default. So that first person had already paid 10 chips. The small blind pays half of that. So he can say, oh, I'm going to throw another 5 in and join this round, or I can fold, right? So the call was saying, I'm going to pay another 5 chips to get up to the 10, which is the minimum to get into this round, right? So you could also raise, and if you raise, then you are elevating the minimum threshold to get into that round, right? You could do that on each round of Texas Hold'em too. So you start with like no cards on the board, right? So when everybody like agrees upon like, okay, we're going to pay 10 chips to get to the next round, it's going to give out 3 cards on the board, and then based on how strong your hand is there, you can raise, you can check, which is say do nothing, right? So in the next round, like you start with a 0 minimum, right? You can just check and not pay anything. You don't have to call, but you don't have to fold either, right?
and that'll just go on to the next person. So then we'll get another card on the board, you can do the same thing. Another card on the board, you can do the same thing. At the end of the 5th card coming up, then you get to actually like evaluate cards, so it comes down head to head. Whoever has a strong stand at the end of that wins the pot at the end. So I hope that made sense. That was not the best explanation of Texas Hold'em in the world. It's not too difficult, I think, if you're kind of a poker person. I'm not, but yeah. That's true, because the rules are like somewhat straightforward, I feel like. So here's some other cool things. So like I made a chat, so I could be like, what's up? And then over here, I'm like, what's up? So like this is super easy to do in Phoenix, over Phoenix channels. So like that was just really cool. I felt like I should do that. I think there's some other cool things I'd like to do. Like I'd like to implement presence, right? Because there's a chance that like maybe this guy, Zach, his internet connection goes down and he's like not there to take action anymore, right? So like what to do in that case? Like Phoenix presence would really help with that a lot. So that's what I'm thinking about maybe doing next with this. Nice. So yeah, that's my little experiment with Elm. Also, if you've never used Elm before, like there's a cool like time traveling debugger thing here where basically it's just updates and messages, right? Like Greg was showing earlier. There's like, you have a model, you receive updates, and then you return basically a new model, right? And that renders your views, so you can like go through all these different things, which is nice. Like that's pretty cool, and it's just there by default when you're developing Elm. So yeah, that's my thing. Also, my code is up on GitHub if you want to take a look or clone it. Z Kaiser is my username, so feel free to take a look at it if you want, or to use it as a reference for getting started with Phoenix and Elm. Yeah. Thank you. Yeah.
The last time I was trying to learn Elm.
Yeah, so I actually just this past weekend spent a good part of Saturday breaking this down into different modules because I kept my like helper functions for views in the same module and it was just getting ridiculously long. This was like 700, 800 lines or something like this. So the ones that I couldn't really organize very well, I just have this extra directory under my page directory where I keep the view helpers here. But I also have a views directory where, so like the chat that you just saw, right? That view logic is all in this module itself. So there's some other things like I was trying to feel out like, so if I want something that I can use on like every page, right, or in different contexts, I call those widgets. So I have like a drop-down widget. And the difference between views and a widget, in my mind, at least the way that I organized it, is that widgets require a context and a configuration. So I configure them from a parent module where I say like, okay, I want you to return like HTML that sends out these kind of messages that the parent has. Whereas with views, they're more self-contained, right? So, and views also have kind of like their own model as well, whereas widgets don't have that. They get their data from their parent.
Is that kind of similar to presentational components and containers in a way? Like smart components and dungeon components?
Yeah, I feel like there's a lot of overlap between, like in React, you would think of like presentational components and container components, right? So my room model is definitely like a container, whereas like these widgets, they're basically dumb, right? I'm just giving them things from their parent to tell them what to do or what to look like or how to render. Yeah, this player toolbar is like the same way. Like you have to pass it a config to use it. So the parent can say, like, what kind of, I don't know, this is kind of a bad example, but like I have in the UI all of these different buttons on the toolbar down here, and I want to say, like, okay, what message do you want me to send off when this button gets pressed, right? So the parent should be in charge of that, I feel like, right? Because the parent is the one that's interested in those messages. The component itself, or the widget itself, right, it can be dumb about that kind of stuff. It doesn't have to know, it could just be told. And then I have some other things that are kind of just popped up, like I have a types directory. I'm not really sure how I feel about that. The only reason I had it is because if you've ever done a lot of development in Elm, you'll see like you'll have circular dependencies where your compiler's like, this module is trying to import this module, and this module is trying to import that, and then you're trying to import that other module up here. So you need a way to kind of break out different types, and I just have this directory there specifically for that reason. I don't know if it's a good pattern or not, but it's working for me at this point. Yeah. And then, so my models essentially they live up here in the data directory. And essentially all these do is like I declare different types or models, and then they have decoder and encoder functions. So that's the one thing about Elm, if you haven't used it a lot, is so handling JSON, you need to decode everything that comes over the wire, and you also need to encode anything that you're pushing over the wire. And you have to know what types they are. So there's some ways to get around that. There's like some dynamic things that you can do. I haven't done anything really complex here, but yeah, that's kind of interesting. It's one of the more difficult things about Elm I've found. Richard Feldman, yeah. Oh, that's.
Decoding and encoding since it is kind of a lot of typing.
Yeah. You said that's QuickType by Richard Feldman?
Elm.quickttype.io. That's definitely worth looking at. Yeah, it may end up being, I'm not sure. They have other languages, so I think it's more than just Elm.
Oh, okay. Is that also the thing that helps you like parse JSON automatically?
Yeah.
Yeah, there's like a thing where you can pass in what you expect the JSON to look like and then write an Elm parser for it.
Yeah.
That's kind of a complicated thing to do.
Right.
So like one of the things too, though, when you're decoding, right? So I have my own data types, like the auth token, right? So like, would it handle that as well? Could you say like, I want you to decode this into this thing that I have?
Yep. And it gives you it would give you all that code. Like, that's awesome. You don't have to write it.
That is really nice.
But it's kind of nice to go through this to understand it.
Yeah, yeah.
You still have to modify it after you generate it.
Exactly.
So have you looked at doing GraphQL from Elm, and I wonder if that kind of solves the transport problem a little bit because you have to define the schema essentially on
Yeah.
Elm.
Yeah, I actually haven't looked at how you would do that with Elm yet, but that's something that I'm really interested in. Like, so especially with Elixir now, right? Like, there's the whole Absinthe is the library for that, and it looks. If you could get an Elm client working with Elixir and Phoenix channels using Absinthe, I think that would be pretty amazing.
Yeah, the subscriptions particularly look super cool, like being able to do GraphQL over channel.
Yeah. So super interested in that. All right. Anything else?
We look at your brunch config? I can do that later.
Sure. Yeah. Actually, it's not complicated. So this is the default Phoenix brunch config, except for this part right here. So I'm using Elm brunch. So I have to specify the main module in Elm, which is under, so everything's under assets, right, in Phoenix 1.3. So Elm source main Elm, that's my entry point. The make parameters, I can actually take this out when I'm not in dev mode. And the output folder is in assets/js. The only thing that got me on this was like I actually had to manually create, where is it? So it gets built, the Elm app gets built into main.js. So I actually had to, before the project would build, I actually had to make main.js, like manually go into the command line and say touch main.js before it did anything. I'm sure there's a way around that, but yeah, that was the only thing that tripped me up.
It probably would have done it if you just run brunch build twice. Like I bet what happened is it built them in parallel, so it built Elm in JavaScript, but at the same time it built everything else in the main app.js. And if you run it again, it'll probably get the previous version's Elm code in it.
That must have been what happened. Because yeah, it was like I can't find main.js, and you're trying to import it in the app.js file. So.
Yeah, you probably set up a dependency in your brunch config. I don't know how to do that. But like in a Webpack, you can say this file depends on that file, and maybe if one of your other files depended on main.js, then it would work. Oh, you know what I bet? It's because Webpack doesn't know that Elm brunch is going to generate that file, so it doesn't have to do the correct.
Yeah. You know what? I'm actually not sure.
I think that's part of what makes you, like, if you have to have that, but I don't know. I think there's another way that you can turn it on and off.
So I think generally with Elm, you would do something like to actually build your project, there's the Elm make tool, and then you just pass in the file, and then you do dash output, the output file, and then you pass in any flags, and so that dash debug is an argument to this. And yeah.
Yeah, you definitely can get rid of that because I don't have it. Right. Well, I'm not doing any of this in production. Yeah, I was using brunch. But I think when I was doing it in production mode, it just didn't have it.
Oh, are you building brunch in like with brunch production?
That's what I would think that does. I figured that would get rid of it, but
Yeah, I bet there's an Elm brunch thing that you have to specify.
Yeah.
I feel like there could be a brunch show and tell session. Like everybody has had pain like setting things up, and I feel like brunch is probably the least painful, but it's still painful.
Yeah.
Suggests very obvious features.
Yeah.
We should build a new one. So we don't have to use
Having had recently upgraded Webpack, like from version 1 to 3.
Ouch.
It makes you question your life choices because it's like Webpack isn't just compiling JavaScript. This should not be complicated.
I don't think Webpack is more than 3. I don't even think it's 3 years old.
Well, that's like an eternity in JavaScript.
Right.
That's true. Has anybody tried Reason? Have you?
Chocolate with the caramel.
It's also really good, I hear.
It's pretty good. It took me a while to get used to doing the bindings, and that was kind of the backbone of like actually using it with JavaScript because Elm has a lot of stuff written in it already, whereas Reason doesn't. So it's my first experience going with
Yeah.
Since it's made by Facebook, it's React binding.
They also have a Reason React library now, which is like exactly React and Reason.
Yeah, it's got some. It has the reducers built in, so it has Elm architecture built in.
So does it do, I mean, do you not have to do the whole action creator pattern? Because you can just like.
Yeah, so it has, because it's OCaml, they're called variants. I'm assuming it's called something similar in Elm, but like.
Yeah, they're union types in Elm.
Yeah. So that's how all of that works. And there are only stateful components like all reducer components, and you're supposed to set it up through reducer and do all of that.
I just started hearing about that a couple months ago, and it looks pretty interesting. I haven't seen anybody do any like Elixir Phoenix like integration with it. Thought that would be pretty cool if somebody's done that.
That could be an interesting next topic for January.
Yeah.
I can bring something in if you want me to.
Yes. Please do.
All right. Thank you.
All right. Did anybody else have a demo? Ben's walking up here. No? No? Okay. All right. All right. Thank you so much, everybody who demoed tonight. On the topic of next month, we heard one topic that we might like to hear. Does anybody have anything else that they would, given a month plus a holiday to prepare, is there anything that anyone would like to hear about? Okay. Oh.
I don't have this well formulated, but I'd like to hear more about like how people are deploying Elixir environments.
Yes. Okay.
How they do database migrations.
I could maybe talk about my experiences with that thus far, but I'm hoping by then maybe somebody else figures out a better way too. So
That our team is focusing on some of those problems.
there's a lot happening in that space, right? Dockyard is working on a kind of open source, I assume open source, deployment tool. Yeah, using releases, yeah. There is kind of a standard or maybe like accepted way of doing database migrations in Phoenix with releases that we could talk about next month. I also have some I've used a couple different Docker container service kind of things to deploy Phoenix applications. I would love to talk about Docker and the Beam and kind of have a discussion about like the advantages and disadvantages and whether Docker actually works well with the ideology of the Beam, maybe. That would be an interesting topic. But
Or even just a survey of several of the options that people have had success with.
yeah.
Because like we currently have several different strategies in production right now. We have enough labs, a lot of things.
I've done a few different Elixir projects in production now, and every single one of them have a different deployment mechanism. So maybe that's a telling sign. So this is the December meetup, and this being the end of the year, I just wanted to say thank you everybody for supporting the Elixir meetup throughout the year and showing up and being brave and getting up and doing demos and being willing to participate in this community. And thank you so much. So hope everybody has a good holiday. Be safe and see you next year.